We are looking to put together a lot of different things today. So, the past few weeks, we have worked on writing compounds, formulas for compounds, making sure a balanced ionic compound is written. We have been recognizing different types of reactions. We have been writing chemical reactions and ensuring that they are balanced. And within the last couple of days, we have looked at writing out a BCA table, a before, a change, and an after, and looking at how much is being used up or how much might be produced in terms of moles. So we're going to add one last step to this. So these problems feel big, and they are, because you're putting a lot of knowledge into these. So what we're adding to these problems now are the gram to mole or mole to gram conversion. You did this in the past. So we are simply putting together all the different pieces that you have been working on for quite a while. So our instructions are to write the balanced chemical equation for each problem. So that's our first step. Use the information that is given to complete a BCA chart. Some conversions will be necessary. Show the math for the conversions off to the side of the BCA chart. Circle or box in the final answer. So we need to read through the problem, determine what's given to us, determine what we are looking for. So solid aluminum metal reacts with chlorine gas to produce solid aluminum chloride crystals. Assuming 100% yield, how many grams of aluminum chloride crystals will be produced if there are 61.5 grams of solid aluminum available? So let's first write our reaction. We have solid aluminum metal that's reacting with chlorine gas. So I have aluminum metal plus chlorine gas. Chlorine is Cl. This gas is diatomic, so we have to write the 2. Aluminum is not diatomic, it's a metal, but our gas is. It's producing solid aluminum chloride crystals. So this yields aluminum chlorine crystals. So let's look at the aluminum chlorine. Aluminum is a +3. Chlorine is a -1. So that means we need 3 chlorines in order for the aluminum chloride to be balanced as a compound. So I have the solid aluminum, the chlorine gas, it yields solid aluminum chloride crystals. So I have the basic skeleton of our reaction. Now we need to make sure that we have a balanced chemical equation. My aluminums are balanced. I have 2 chlorines here, 3 chlorines here. So we need to figure out what number do they both go into and then multiply that. 2 and 3 both go into 6. So how do I get 6 here? I multiply this by 2. How do I get 6 here? I multiply this by 3. So I have 6 chlorines, 6 chlorines. Now I have 2 aluminums here, so I need to make sure I have 2 aluminums here. So it looks like I have a balanced chemical equation. Now we are told that we need to find the number of grams of aluminum chloride crystals. So this is what we are looking for here. This is our question mark. How much? If there are 61.5 grams of solid aluminum available. So we're given grams, and we can change the grams to moles, and that's what we use in our BCA table, our number of moles. So if I have 61.5 grams of aluminum, I need moles. 1 mole of aluminum, I look in my periodic table. Periodic table, aluminum is about 27 grams. So 27 grams. I have 61.5 divided by 27. And that gives us 2.27 repeating. And these are our moles. So this is our before, change, after. So I know that I am starting with 2.28 moles of aluminum. We're assuming that we're using all of this up, and I will have 0 after. We're being asked to find the grams of solid aluminum, we're asked to find the grams of aluminum chloride crystals. So we don't necessarily need to worry about our chlorine gas. We start with 0 aluminum chloride. Our change is going to be looking at the ratio between the aluminum and the aluminum chloride. It's a 2-to-2 ratio. So it's a 2-to-2 ratio of the 2.28. So that means we just have, this is a ratio of 1-to-1, so we will gain the 2.28 moles of aluminum chloride. These are moles. We are asked to determine grams, so we will do another conversion. We will take our 2.28 moles of aluminum chloride and change it to grams. So 1 mole of aluminum chloride has a molar mass of 27 for aluminum plus 3 of chlorine. Chlorine is 35.453, so that gives us a molar mass of 133.4. So I'm going to multiply that by 2.28, and that gives us 304.1 grams of aluminum chloride. I am going to work on problem number 2 if you want to continue to follow along. If not, continue to work on problems 2, 3, 4, 5, and 6 on your own. Problem number 2. We have 15.45 grams of solid potassium chlorate, which decomposes when heated to form solid potassium chloride and oxygen gas. Assuming 100% yield, how many grams of solid potassium chloride will be produced? So let's write our balanced chemical equation first. So I have solid potassium chlorate. So potassium chlorate, potassium is K. Chlorate, if I'm not sure, I'm going to go look at my ion chart. Chlorate is ClO3. Potassium is a +1 charge. Chlorate is a -1 charge. So this formula is balanced. It decomposes, so that means we have a decomposition reaction. So here's our one that's decomposing into a couple of others. So it decomposes to form solid potassium chloride. So potassium chloride is KCl. Potassium is a +1. Chlorine is a -1. And oxygen gas. Oxygen is O. Oxygen gas is diatomic. It's O2. This KCl is balanced, KClO3 is balanced, O2 is fine as it is. Now let's look at the reaction itself. Is it balanced? I have 1 potassium, 1 chlorine. Here I have 3 oxygen, here I have 2 oxygen. 2 times 3 is 6, so I want 6 oxygen on each side. I'm going to put a 3 here and a 2 here, and I need a 2 here. 2 potassium, 2 chlorine, 6 oxygen, 6 oxygen. All right, so I have my ratio built because I have a balanced equation. So let's look at what we're starting with. We're starting with 15.45 grams of solid potassium chlorate. So 15.45 grams of KClO3. I need to change that to moles because I put the moles in my table. So 1 mole KClO3. So potassium is 39.1 plus chlorine is 35.453 plus 3 oxygen. Oxygen is 16. So altogether I should have 122.55 grams. So I'm going to take my 15.45 and divide it by my 122. So 15.45 divided by my 122.55. And that gives us 0.126. I'm going to round it up to 0.13 moles. So this is my before, my change, and my after. We're assuming that we will use up all of potassium chlorate. It decomposes all the way. So what we're being asked to find is how much potassium chloride. So I'm looking for this, the potassium chloride. So remember, we start with 0 on our product side. There's a 2-to-2 ratio, which is essentially 1, which means that we will end up with 0.13.